All right, good evening and welcome back to College Algebra. If I recall, we were right in the middle of doing a parabola problem, so I think we should just pick it up there and keep going. I don't know if this was exactly the right one, but it's as good as any. Okay, so today what we're gonna do is we're probably gonna finish this section today because we've got some word problems to deal with, and that's about it. We got that. All right, let's go back to this one here. Nope. All right, so here we have 3x squared minus 9x minus 2. Okay, so we'll get some drawing here. Plus, so we have 3x squared minus 9x minus 2. That's my function. And first thing you do is identify it as a parabola, right? We have 1 squared, so that's a parabola. It opens up because the first coefficient is positive, so it opens up, it's a parabola. And let's see what the next couple of questions are going to be here. So identify the vertex. So again, this is not one I would want to do a complete the square problem on. This is x is equal to negative b over 2a kind of a problem. All right. So we're going to type in x equals negative b, which is negative 9 divided by 2 times 3. That's the a. So we have 9 over 2 times 3, and I think that's going to give us 3 halves, right? Minus 3 times 3, the 3's cancel, we get 3 halves. But don't answer yet because we also need the y part, right? This is the x part of the vertex. We also need the y part of the vertex, so it's going to be 3 over 2 squared minus 9 times 3 over 2 minus 2, right? That's what it's going to be. It's going to be 9/27 over 4 minus 27 over 2, okay, minus 2. All right, lazy about that, so it's 27 fourths minus 27 halves, 27, right, and then minus 2. All right, and you could leave it like this, that's fine if you want to turn it into a fraction, because maybe the book will demand that you do a fraction. That's how you do that. So this is going to be either negative 8.75 or what do we have here? Negative 35 fourths. Whatever your pleasure. This is the y part of the vertex. Right. So if I wanted to tell it what the vertex was, right, it would be 1.5, negative 8.75. All right, that's our vertex. Oops. All right, determine the x-intercepts. Okay, so in determining the x-intercepts, that means we have to set y to be 0. All right, so setting y to be 0, we'd have 3x squared minus 9x minus 2, that is equal to 0. And what we're going to do here is we are going to have to use quadratic formula because I can't factor this. Okay, because 3 times negative 2, that's going to give me negative 6. Can you think of 2 things that multiply out to negative 6 but add up to negative 9? Like I don't have one of those, so this can't be factored. We are going to have to deal with quadratic formula here. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so let's type in what we have, right? We have negative 9 plus or minus the square root of negative 9 squared minus 4. A is my 3, B is, or C rather, is my negative 2. All over 2 times 3. Okay. So simplifying this a little bit, right? We have x is equal to 9 plus or minus. And then here, what are we going to have? We have 81, right? Because 9 squared is 81. And then we have minus a minus, so it's going to be a plus. And then we have 3 times 4, so that's 12. 12 times 2 is 24. And it looks like it's going to be 105, which is 5 times 21. And that is not going to give us a very nice square root. Divided by 6. Okay, so our two values here, right? My two x values are going to be 9 plus the square root of 105, all divided by 6. And then x equals 9 minus the square root of 105, all divided by 6. Okay, I know it's a little bit bigger than 10. That's all I really care about. Looking at this, and I'm sure these are both delightful numbers. Okay, what's the y value here? Well, the y value was, we set y to 0. So the y values in both of these cases, y equals 0, y equals 0. Okay, that's where it crosses the axis. All right, so let's see here. What else are they going to? Oh, they want to know the, that was the x-intercept, and they want to know the y-intercept. Well, y had a turn at being 0. Now we're going to set x equal to 0. Okay, so we're going back to the original function. We're going to say this is 3x squared minus 9x minus 2. We're going to set x equal to 0. We have 0 minus 2. Oh, so when x equals 0, y is minus 2. Okay, and that's my y-intercept. Okay, what else do they want to ask us? Okay, sketch the function. We'll use the tool to do that. Okay, determine the axis of symmetry. Well, they already asked us that, right? They already said what's the axis of symmetry. Well, they asked us what the vertex was. And since we know the vertex is 1.5 negative 8.75, when I go to graph this thing, there's 1 and 2, 3 houses in the middle. I know that's going to be my axis of symmetry, right? X equals 3 halves is my axis of symmetry. Right? And then they're going to ask us a bunch of stuff that we already know because we know the vertex is down here, and we'll get something like this. All right. And we'll have to know that, right, that this is a minimum, and they're going to ask us domain and range stuff. But again, once we know the vertex, we have the general shape. I don't know why they keep asking that question, but they do, so be it. We can go through. All right, so graph opens upwards. Okay, oh, they're going to take me through it this way. This was 3, oh, this, I'll put it in decimals, 1.5. And we'll say this was negative 8.75 or 25. Let's see. 8.75, of course it was. All right. Oh, check. It didn't even complain. Okay, great. Determine the x-intercepts. Oh boy. So what do we have here? We had a fraction. We had 9 plus the square root of 105 all over 6. Oops, what did I need to do? I needed to do this. Can I do this? No, I can't. V and 0. And then we need a comma. And then another one of these. All right, and then Control V because it's still in there, except we have to change this to a negative and 0. All right, happy there. Y-intercept, we found that out. That was 0, negative 2. All right, and then we have to sketch it. Okay, so we could plot, right? We could plot our vertices, or yeah. So that's going to be 1.5 and negative 8.75, and that tells me where the vertex is, right? So we have a point plotted there. Let's also plot the point 0, negative 2, just because I don't want to have to stare at this graph and try to get that. So now when I'm going to plot this, it's like place the vertex. Okay, we have a point that we put down. It opens up, and then we're going to go ahead and match that other point there. Okay, and then check. Okay. Generally, when you use that plotting tool, they really appreciate you if you use a fraction or square root rather than a decimal approximation. Okay, if it's 0.5s or 0.25s, I don't think you're going to care. But generally, if it's like 17/3, tell it 17/3. Don't do decimals on it, because it will tell you that's the wrong answer, and I'll have to look at it and it's like, why is that wrong? Like, oh, because you used 17.333 instead of something else. Okay. Determine the axis of symmetry. X equals, right? X equals 1.5 because it's at the vertex, right? It's going right down here. Okay, the function n has a minimum value, right? And that minimum value was negative 8.75. All right. And then again, the domain, I don't know why they ask you the domain every time. Okay, I guess just in case you only did one, they wanted to make sure. And the range, right, is going to be negative 8.75. And it goes up, up, and away because that was the minimum. And there we go. We got it. Okay. So hopefully, as you're doing these, the problems become more and more comfortable so that you can kind of fill these in, and it takes less and less time for you to do so. Okay, we get more practice. Okay, these ones were very straightforward. I'm going to go ahead and skip these, and we can look at the word problems. Okay, so here we have it, right? We have the population of a bacterium, and here's our population value. Here's a brief insight into why we use the words A, B, and C to cover these numbers, because they are often, you'll see this in one of the other problems, these are often 4 decimal numbers, 5 decimal numbers. They're not very fun. So the reason why we do A, B, and C is because we would rather have that as a handle than try to deal with everything else. Okay, so population, okay, let's see. Determine the time in which population is a maximum. All right. So what are we doing here? So we've got P of T is equal to negative 1688T squared plus 78,000 T plus 10K. All right. Now, whatever else I know about this parabola, just by looking at how it's laid out here, I know the graph looks something like this. Okay. I don't know, well, I guess T starts at 10,000, so I guess it's up here somewhere. But I know it opens down, right? So it's going to be somewhere over here somewhere. Okay. So wherever it's a maximum is going to be where our vertex is. So where's the vertex? Right? And we're going to say the vertex is negative b over 2a. So that's going to be negative 78,000 divided by twice negative 1688. Okay, and then let's go ahead and just calculate that out there. So that's going to be negative 78,000, sorry, divided by, and then we're going to say parentheses, negative 2 times 1688. All right, and we got x was equal, or t is equal to, come back here, what was that, 23.1? We'll say 23 because it says nearest hour, so they want us to just round to the nearest one, so 23. Okay, there's our value there. Okay, so after 23 hours. All right. Determine the maximum population. Well, right, it's P of t. So once we found out when it happens, they want to know what is it. So even though we found this value here, we're going to plug this in, and we're going to say, okay, well, P of 23, that equals negative 1688 times 23 squared plus 78,000. Just 3 zeros, if you please. And then we're going to put in a 23 there, and then plus the 10K that we had. And I definitely using a calculator for this because there's no way. Negative 1688 times 23 squared plus 78,000 times 23 plus 10,000. All right, so 91, what do we have here? 911. Okay, 3 of them, and then 048. All right, 911048. Let's see what we're supposed to round to. Oh, it's approximately fine. 911, comma 048. There we go. Glad it gave me some amount of, oh, that was all they wanted. Okay, well, that's great. They're not going to ask me anything else. One of the things I might ask is, where is this thing equal to 0? Because they didn't tell us a domain. Clearly, right? It looks like this. So when t equals 0, we've started with 10,000. Right? When t equals 0, we had 10,000 here, because if I plug in t equals 0 here, 10,000. But somewhere along the way, right, it's going to cross. So you might have to use the quadratic formula on this one. I might ask that, right? When is a good domain for this function? And you're going to say 0 to wherever this point is. Find out the quadratic formula. All right. In the interest of getting along with what we have to do here, let's go ahead and continue. All right. So yeah, I wanted to show you. I've used this problem before. This was a problem that I have used as a test one before. Okay. So we have a gas mileage. Okay. And again, right. By the way, well, I don't know if they still do it. They were doing this when I went to school. So at least in the 20th century, popular mechanics would do an article on this every year to show you what the optimal gas, what speed you should have for optimal gas mileage. Okay. So let's see here. We have m of x is equal to negative 0.028 x squared plus 2.636x minus 35.015. Okay, and honestly, this is a very typical type of equation that you would see in any time where they're going to take math and actually use it. Okay, and they say x is miles per hour, and m of x is your mileage, miles per gallon. Okay. And then what are they going to ask? Okay. Determine at which speed the car gets its maximum mileage, because it's not true. I see people say this. It is not true. The faster you go, right, you're gonna burn gas too much. But there is a point, right, that it's optimal. So you're going to be able to get your highest distance, right, at that particular speed. So max. How do I know it's a max? Because that's negative, so I know the parabola looks something like that. Okay. I know the parabola is facing down. So the max is the vertex, and it is at negative b over 2a, and that happens to be at negative 2.636 divided by twice, negative 0.028. All right. And again, if you just drop the negative signs, because negative over negative is going to be positive, nobody's going to call you out for that. 636 divided by in parentheses twice, negative 0.028, I believe. I should have just dropped the negatives. So 47 miles per hour is your optimal speed. Okay, so if you're coasting past Needles and you forgot to get gas there, that's where you are. Okay, that's the speed you need to go in order to get to the next town. All right. Hopefully it's late at night and nobody pulls you over for that. All right. Determine the maximum gas mileage. Okay, so once we know what the speed it is, we're going to figure out what the miles per gallon actually is at that point. Okay, so we're going to take this 47, we're going to plug it back in. So M of 47 is equal to negative 0.028 times 47 squared plus 2.636 times 47 minus 35.015. By the way, this is definitely one of these models where they would say, like, yeah, we tested speeds from 10 miles an hour to 80 miles an hour or something. Because look here, if I put a 0 in, right, my gas mileage is going to be negative 35.015, which means if I'm not moving, I'm getting gas. I'm getting gas somehow. So you know, realize that this is definitely a restricted domain kind of a problem. It's not going to work for all speeds. Okay, so we have negative 0.028 times 47 squared plus 2.636. Oops. How about insert plus? Okay, 2.336 times 47. Okay, minus 35.015. Okay, so that's going to be 27.025 really. Well, 27, I didn't carry decimal places over here. So at 47 miles an hour, we're going to get 27 miles per gallon. Okay, so we end up with 27 there. Oops. It's a 0.1. Oops, what did I say? 27.0. All right, let me check. All right. So that is a very, like I said, I've used this problem before. This is a very typical kind of problem that I would deal with. Okay. This, on the other hand, is not a problem I like to deal with because, quite frankly, these kinds of problems I find terrorize students, so I try not to use them. I also don't like to use train problems. So we have the difference of two numbers is 12. And they want what two numbers will maximize the product. So how do we do this? We're going to say something clever, like let's pick two numbers. We're going to say A minus B is equal to 12. And then what we want to do, product, okay? Well, we'll just say product right now, is equal to A times B. Right? So here we have two equations. We have two unknowns. That's really the inventory you want to deal with before you run off and do anything else, okay? So once you know the number of equations, once you know the number of unknowns you have, that means you can solve problems, okay? So right away, we're going to say A is equal to, well, it doesn't really matter which one you use, but we'll say A is equal to 12 plus B, okay? That's equation 1, that's equation 2. Now what we're going to do is we're going to take equation 1 and we're going to push it into equation 2. Okay, so we're going to have this product of B. We'll say A, what's A? A is 12 plus B. What's B? I think I should have something of a negative in here. I really do. All right, well, we have a B squared plus 12B equals our product. Let's see what happens here, okay? The difference of two numbers is 12. What two numbers will, oh, minimize the product. Okay, that's what it would minimize. That would make sense because I know this parabola, right, looks something like this. All right. So we have one, you know what? Because we're going to use A's, B's, and C's here, I probably should have called this something else. Okay, but the middle term, okay? So vertex is negative, I'll use capital B over 2A. I'll use that. Okay, so we're going to have, this is going to be negative 12 over 2 times 1. Okay, so negative 12 over 2, that's equal to negative 6. All right, so we know that that's B, right? It's when B is equal to negative 6, I know I've got a minimum product here. What's that going to be? So we know that A minus B is equal to 12. So A is equal to B, or 12 plus B. What's B? B was negative 6, so A is equal to 12 plus negative 6. A is equal to positive 6. Okay, so negative 36 happens to be the minimum amount I can have to fulfill all of this thing here. Okay, so we have first number 6, second number negative 6. All right. Okay, so those are good problems to do. You should probably, you should definitely do some homework to understand them. They do get easier with practice, but I also understand that this gives people night sweats, and I generally will not ask this kind of a question because of that. I know how you feel with that one. I much rather like the gas problem. I much rather like the bacterial problem. They're all the same problem, so why not minimize the anxiety, right? And do that. Okay, this is also a very good problem. Okay, this is also one that I would have used before, so this is a good one. So we want family wants to fence in an area of the yard for a vegetable garden to keep out deer. One side is already fenced from a neighbor's property. Okay, so you're looking at somebody's got a fence already up. They're just going to put this extra fencing up here. Okay, the family has enough money to buy 120 feet of fencing. What dimensions will produce the maximum area of the garden? Okay, so let's draw a little picture here. Okay, they're nice. They never did this. Okay, so this is a wall. This is already fenced. I'm always amused when they draw this and I was like next to a river. Like, putting a fence around a river is not going to keep anything out, okay? All right, so that's our value here. So if we go around the sides here, the perimeter problem, right, I've got 2 x's plus a y, and how much fencing did they tell us to have? Well, they said that we had a maximum of 120. Okay, and then the area, right, is equal to x times y. So again, we have 2 equations. We have 1, 2 unknowns. Okay, so what we're going to do is we're going to use equation 1, and we're going to substitute into it for equation 2. So we're going to do something clever here with equation 1. We're going to say this is 2x plus y is equal to 120. I always say that y is equal to 120 minus 2x. Let's push that to the other side. All right, so we're going to have a is equal to x, and then what was y? Well, we're going to take this equation, we're going to push it into equation number 2. Y is 120 minus 2x. Okay, let's go ahead and fix this. So we're going to have my area is equal to 120x minus 2x squared. We could rearrange that if you want. That. Now we have to find the vertex. I'm going to show you one special little thing when we're done here. So that's going to be negative b over 2a. Okay, that's x equals negative b over 2a. That's my vertex. That's the maximum area. How do I know it's going to be maximum? It's because this a is negative, so I know this probably looks something like that. So we have negative 120 all over 2 times negative 2. Right? This one I can do, right? That's going to be 30, x equals 30. So we have to go back to equation 1, right? We have x equals 30 for equation 1, and we're going to say y is equal to 120 minus 2 times 30, y must be 60. Okay, we'll do that. Okay, let me show you one clever little thing about vertices. If I go back to my equation here, right, we have negative 2x squared plus 120x. I could factor out, right? I could factor out a negative 2x here. And what do we have left? We have a positive x, because I multiply that back, minus, and I pulled a 2 out. That's x equals 60. Set this equal to 0. So my intercepts, right? My y-intercept, my x-intercept, right? That's going to be x equals 0 and x equals 60. Right? We can do that. Now, if I add them together, I take their average, we get 30. When we got our vertex, what did we get? We got 30. That is no accident. Okay, that is always the way that that works. So if it's easier for you to factor it and then average the intercepts, that could be how you find the vertex, and that's okay. Because again, it's an axis of symmetry. It's the same, right, on both sides. And the vertex, if you know where these are, then it's got to be in the center of where the intercepts are. Okay, so that's always going to work. I thought I always found that to be really neat and really clever. And when I teach statistics and we have to do something like this is exactly what we do. Is we take the average and then get the vertices that way. We don't go through a lot of this because they don't need the algebra. So we just average the intercepts and then we're done. Okay. So all right, where we are. Okay. This is a good problem, by the way. This is 30 by 60. We got a little green check mark for us. And we're good. So that pretty much finishes out, I think, 2.1 for us. Tomorrow I will start 2.2 and we'll keep going with that one. I remember that 2.2 is going to be a little on the difficult side for us. Well, yeah, 2.2 has some interesting problems in it. I'll just leave it at that. So I'm going to stop here, and I wish everybody a good night.